I'm going to be reviewing different markup tools available inside of Autocad. I'm going to be marking up a drawing using the RevCloud command. And I'm going to use the multileader tool to add a revision tag to the RevCloud. You can create a revision cloud by selecting two corner points using the rectangular option, or polygonal points to create a polygonal shape, dragging your cursor, or you can convert an object such as a circle, polyline, spline, or an ellipse into a revision cloud. Revision clouds highlight parts of a drawing that are being reviewed or need to be modified. We're going to revise a floor plan. I'm going to be marking up this drawing to demolish the staff room area and add a cafe area with an espresso bar. I'm going to start by adding a revision cloud. I switch to the markup layer using the layer drop-down list on the home ribbon. The revision cloud tool is located on the Annotate tab of the ribbon. On the RevCloud flyout, I have three options: polygonal, rectangular, and freehand. I select the polygonal revision cloud. I select some points to define the shape of my polygon. Once I have defined the boundary for my RevCloud, I right-click and select Enter. The polygonal tool is useful if you want to create an irregular shape for your revision cloud. I'm going to place another RevCloud using the rectangular option. I select the rectangular RevCloud control. For the rectangular RevCloud control, instead of having to select a series of points, you just need to select 2 points, just like creating a rectangle. I'm going to convert an ellipse to a RevCloud using the object method. First, I return to the Home tab on the ribbon and select the ellipse command. I place an ellipse over this wall by selecting a center point and then an end point. I select another point to set the width of the ellipse. I right-click and select Recent Input RevCloud. I select the arc length option on the command prompt. I set a minimum arc length of 100. The maximum arc length has to be no more than 3 times the minimum arc length value. So I type 300 and press Enter. I then select the Object option on the command prompt. I select the ellipse to convert the ellipse to a RevCloud. I select No to reverse the direction. To modify a RevCloud, I repeat the RevCloud command. I select the Modify option. I then draw a new boundary for the RevCloud. I am prompted for a side to erase. I select the portion of the RevCloud to be erased. Autocad prompts me if I want to reverse the direction of the RevCloud. If I select Yes, notice that the arcs will invert. I want to add a revision tag. I can use the multileader tool to add a revision tag. First, I'm going to create a new multileader style. I select the small arrow in the Leaders panel on the Annotate tab. I select the New button. I type Rev tag for the new style name. I select the Continue button. I activate the Content tab. I select Block under Source Block. I select Triangle. I select OK. The current multileader style is displayed as Rev tag, and the preview window displays what the Rev tag is going to look like. I select Close to close the dialog box. I select the multileader tool from the ribbon. I select a point on the RevCloud to place the leader arrowhead and then pick to place the Rev tag. A dialog opens to prompt me for the revision tag label. I type in the number 1 and select OK. My multileader is really small and I want to fix that. I select the multileader, right-click, and select Properties. My multileader is really small because the drawing is using millimeter units. I change the overall scale of the Rev tag to 25. The Rev tag resizes. I close the Properties dialog. I press Escape to release the selected multileader. In this lesson, you learned how to place a revision cloud using different options. We modified the RevCloud appearance using the arc length option. We used the Modify option to change the RevCloud boundary. We used the multileader command to place a revision tag. and we used properties to change the scale of the multileader. The Wipeout tool creates a polygonal area that masks underlying objects with the current background color. The Wipeout area is bounded by a frame that you can turn on or off. You can also choose to display the frame on screen and have it hidden for plotting. In a previous lesson, we added revision clouds to indicate the walls and doors which need to be demolished in the floor plan. In this lesson, we're going to use the Wipeout tool to see what the space will look like with the walls and doors removed. I select the Wipeout tool from the Markup panel on the Annotate tab. I go around the area, picking points to select a boundary around the area which I want to be concealed. To hide the Wipeout boundary, I right-click and select Repeat Wipeout. I select the Frames option. I can select On, Off, or Display, but do not plot. I select Off. The Wipeout frame's visibility is turned off. I'm going to insert a door block in the center of the remaining wall. I select the Insert ribbon. I select the Insert Block tool. I select the drop-down to launch the Blocks palette. I select the Current Drawing tab. I scroll down until I see the dynamic door block. I drag and drop the door block into my drawing to place the door. I want the door to be on the same layer as the other doors. To do that, I'm going to use the Match Prop tool. I select Match Properties from the window. I select a cyan door as the source object, and then select the door I just placed. I press Enter. The door now is on the correct layer. I hover over the arrow control on the door block and select Non-Threshold Door. The lines displaying the threshold are no longer displayed. I use the block grips to adjust the size of the door to 800 millimeters. Next, I'm going to use the Wipeout tool to hide the wall lines inside the door threshold using a polyline. I select the Polyline tool from the Draw panel on the Home tab. I select the inside points of the door to draw the polyline. If I need to, I can use a multifunctional grip to add a vertex to the polyline and adjust the shape. I right-click and select Recent Input Wipeout. I select the Polyline option on the command prompt. I select the polyline. AutoCAD prompts me to see if I want to erase the polyline. I select Yes. The walls are now masked as well. In this lesson, we used wipeouts to mask some elements in our drawing to see how changes would appear. The Wipeout tool is useful when you want to explore different options without having to delete or modify existing elements in your drawing. We're going to use the Drawing Compare tool to help us see the differences between the drawing we have and an updated drawing that just landed in our inbox from an outside vendor. The Drawing Compare tool is located on the Collaborate tab. I switch to the Collaborate tab on the ribbon and select the Drawing Compare tool. I browse for the drawing I just received from my vendor. The differences are shown in red and green. If you select the Settings tool on the far left of the Drawing Compare toolbar, you see a legend on how to interpret what you see. The red elements belong to the selected drawing, not the current drawing, and the green elements are in the current drawing only. Drawing Compare also placed a yellow rev cloud around the area that was changed to help me focus my attention. To exit the Drawing Compare mode, select the green check on the toolbar. We're going to be looking at how to create, modify, and apply text styles. Text styles are used to manage and automate almost every aspect of your text objects. Text styles allow you to maintain consistency in your drawing annotations and to organize your text. To automate text standards at your company, you can add text styles to your company-wide drawing template, making it very easy for all users to follow your text placement standards. Most characteristics of your text are controlled by the text style, including the font, text height, and width factor. AutoCAD also has some pretty nifty text features where you can leverage some of the existing data inside your drawing by inserting fields into text elements. We're also going to modify some text properties to adjust its appearance. AutoCAD has a built-in spell check and even allows users to add words to a custom dictionary. I'm working in a plumbing plan for a golf course clubhouse. I want to create a new text style and apply it to the notes. The text style tool is located in the lower annotation panel on the Home tab. I select the text style tool. I select New. I call my new text style General Notes and click OK. I'm going to use Open Sans for my font. Here's a neat trick. If you type the first couple of letters of the desired font, AutoCAD will drop you down to that location in the fonts list. I click Apply and Close. To change the text style for my existing mText elements, I select the two text objects and select General Notes from the text style list on the Annotation panel. I click Escape to release my selections. I'm going to switch to Layout 1. Most title blocks use attributes, but in this case the title block is just using text objects. I'm going to go to the Application menu so I can display the drawing properties. I want you to see what properties are currently associated with this drawing. I select Drawing Utilities, Drawing Properties. I select the Summary tab. Notice I have filled in a title and the name of the drafter. I click OK. I go over to the title block. I click on the drawn text. I right-click and select Insert Field. I select Document under Field Category and highlight Author. I click OK. The field is inserted. I select the date text. I right-click and select Insert Field. I select Date and Time under Field Category and select my desired date format. I click OK. I select the file name text. I right-click and select Insert Field. I select Document under Field Category and select File Name. I enable File Name Only so that only the file name is displayed. I disable Display File Extension so the DWG file extension won't be displayed. I click OK. I select the mText tool from the Home tab on the ribbon. I place the rectangle for the mText inside the drawing title area in the title block. I select the Field tool from the ribbon. I select Document under Field Category and select Title. I click OK. I highlight the text and adjust the text height. I select the Center Justification from the Text Formatting bar. The mText adjusts to Center Justification. My last task is to perform a spell check. The spell check tool is located on the text panel of the Annotate tab. I select spell check. I can spell check the entire drawing, or I can select an area or object to spell check. I choose selected objects from the drop-down list. I then use the pick option to allow me to select the drawing notes and a dimension located on the left side of the floor plan. I click Enter to complete my selection. I click Start on the check spelling dialog box. Like many designers, I use acronyms and technical terms in my notes. I don't want to be prompted every time certain acronyms are tagged like hot water, so I select Add to Dictionary. I do the same with cold water and ventilator. I hit my first misspelled word. AutoCAD offers me a list of possible corrections. The one on top is the one I want, so it's highlighted, and I click the Change button to make the fix. I correct the misspelled word. I correct the next misspelled word. The next word that is caught is hand sink, but that word is correct, so I'm going to add it to the dictionary. I misspelled the word overall, which I had added to this dimension. The spell check tool caught the error, and I select the change button to correct it. Autocad lets me know the spelling check is complete, so I click OK and close the dialog. Sometimes when you have a lot of text, it's helpful to use columns to organize your text. You can create and edit multiple columns in multi-line text using the in-place text editor column options and column grips. Editing columns using grips provides you the flexibility of seeing the changes as you make them. Columns follow a few rules. All columns have equal width and equal gutters. A gutter is the space between the columns. The height of the columns remains constant unless more text than the column can accommodate is added, or you manually move the editing grip to adjust the column height. When you are working with columns in the in-place text editor, the columns are in a frame. The ruler bar spans across all columns but is only active for the current column. Text basically runs from the first column into the adjacent column. You can control the amount of text in each column by resizing the column widths and the overall size of the text box. I'm going to start the mText tool from the Annotation panel on the Home tab of the ribbon. I select two corners to define my text box. The text editor appears. I select the standard text style and set the text height to 50 millimeters. I want to import a Word document into my text, so I'm going to right-click and select Import Text. I browse to the folder where I'm storing my general notes. The document is in TXT format. If you check the Files of Type drop-down list, AutoCAD allows you to import a text file or an RTF file. I select the general notes.txt file. I select Open. The text is imported. I close the text editor. I use my zoom to see my text. I double-click on the text to edit it. I zoom out to see the mText boundary. I use the grips to adjust the size of the mText. I reselect the text and I want to change the text to use columns. I select the Dynamic Columns option from the ribbon. As I drag the mText window, I can adjust the mText. Notice that the text just runs into the next column. I can use the grips on the mText box to adjust the number of columns and the size of the text object. I can also use the static columns to adjust the number of columns. I change the number of columns to 3. I want to adjust the gutter size. Remember, the gutter is the amount of space between columns. I right-click inside the mText and select Columns, Column Settings. I adjust the size of the gutter to 100 millimeters. I click OK. I click outside the mText to exit the editor. I reselect the mText to activate the grips. I can use the grips to resize the mText object. In this lesson, we reviewed some of the tools available when creating and adjusting text columns. You can import a text file into your mText object easily and then use static or dynamic columns to modify the appearance of your text. Have you tried creating tables in AutoCAD? Many drawings contain a variety of schedules, parts lists, bills of materials, and price lists that require a table. While creating a table manually by copying and offsetting lines is not hard, you can save a lot of time by using the table command. A table is a compound object that contains information arranged in rows and columns. Similar to most spreadsheet applications, the rows and columns can be adjusted with grips, and styles can be assigned to the table and to selected cells. In this lesson, we're going to insert a table object and add some cell data. To insert a table, I can use the Table tool from the Annotation panel on the ribbon. I select the Table tool and a dialog box opens. I'm going to set the number of columns to 4 and the number of data rows to 7. I press OK. I select a point to place the table and then select a second point to specify the table width. I type in the necessary column headers for my parts list. I can use the Tab key to advance to the next column. I'm going to type item for the first column, part number for the second column, description for the third column, and quantity for the fourth column. To advance to the next row, I can press the Enter key. I fill in the item numbers starting at the top row and going down. I want to center the item numbers in the first column. To do that, I highlight the column and right-click. I select Alignment, Middle Center. I press Escape to release the selection. The item numbers adjust their position. I enter in the remaining information. I want to delete the last 2 rows of the table. I highlight those rows. To select both rows, I press the Shift key. I select Delete Rows from the ribbon. I adjust the alignment of the quantity column using the same method applied to the item column. I highlight the column and right-click. I select Alignment, Middle Center. I press Escape to release the selection. I want to insert a symbol from the character map into one of the cells. I select inside the cell. I select the drop-down list next to the @ symbol and select Other to launch the character map. I highlight the registered trademark symbol and choose the Select button. The symbol appears in the Characters to Copy area. I select the Copy button. I right-click inside the cell and select Paste. The special symbol has been placed. I want to insert a field into the table as well. I select the desired cell to activate. I select Insert Field. I select Hyperlink to use a hyperlink as a field. I select the Hyperlink button to define the hyperlink. I select the File button to browse for the desired file. I locate the PDF file I want to use for my spec sheet. I type Surge Protector Parts List in the Text to Display field. I press OK. I press OK to close. To turn off the shading behind the field, I type Field Display and set the value to 0. In this lesson, we're going to be adding multileaders to a drawing. A multileader object typically consists of an arrowhead, a horizontal landing, a leader line or curve, and either a multiline text object or a block. Autocad comes with several predefined blocks which can be used with multileaders, or you can define your own block to be used with a multileader. If you are using mText, you can assign the desired text style to be used by the mText object. I'm going to start by defining a multileader style to be used for my item balloons. To define the ML leader style, I use the expanded area on the Annotation panel on the Home ribbon. I select the ML leader style tool. I already have a few styles defined in my drawing. If I want to see what they look like, I can highlight the style name and the preview window displays a preview of the style. I select the New button. I type Item Balloon for my style name. I press Continue. I select the Content tab. I set my multileader type to use a block. You can see that I have the choice of using a block, mText, or none. I select the circle as my source block. I change my scale to 2, and you see the preview adjusts to the new scale. I press OK. I verify that the current multileader style is set to item balloon. I press Close. My mLeader command is located on the Annotation panel on the Home ribbon. I select the mLeader tool from the ribbon. I right-click and select Options. Notice that I can change the leader type, the leader landing, the content type, the number of points used, or the angles applied when creating my leader. I select the leader type option. The leader type is currently set to straight, as this is how I define my style. I'm going to change it to spline, just to see what that looks like. I exit the options. Autocad prompts me to place my arrowhead location. I pick in my window to place the arrowhead for my leader. I want to make sure ortho is set to off, as that can interfere with the placement of the leaders. I select the location for the block, and the attribute dialog appears. I type in the number 5. I'm going to place another multileader for the cable. I right-click and select Repeat mLeader. I place my multileader. Notice that this multileader uses the definition of the mLeader style. I want to collect the 2 item balloons so they are together. I go up to the ribbon and I select the Collect tool located in the mLeader drop-down list. I select the 2 multileaders and then pick in the window to place the collected multileaders. Notice the style that's used by the collected multileaders. I'm going to place the additional multileaders I want for this drawing. I right-click and select Recent Input and select the mLeader command. I place the additional multileaders using the item numbers shown in the parts list. I want to add additional leaders to one of the item balloons to indicate additional parts. I can use the Add Leader tool from the ribbon. I select the multileader to be modified and place the additional desired leaders. I press Enter to exit the command. I placed a leader to the wrong component. It needs to be removed. I select the Remove Leader tool from the ribbon. I select the mLeader to be modified. I select the leader to be removed. I press Enter. I want to align my leaders. I select the Align tool from the ribbon. I select the multileaders I want to align. I can use a window or crossing to select my multileaders. I right-click and select Options. I select the Distribute option. I then select the first multileader to align to. I use my cursor to position and align the multileaders. And then I pick to select my desired positioning. We're going to be dimensioning a floor plan. In order to do that, we need to create a dimension style. I'm going to walk you through how to place more than one dimension at a time. Some of the tools I'm going to show you will significantly improve your productivity. I'll show you how you can modify a dimension simply by using the associate method of moving an extension line. We can add dimension breaks to make it easier to discern which dimensions apply to what objects, and control dimension spacing so that dimensions aren't too close together to make them easier to read. We're going to start by creating a dimension style. We define a dimension style by going to the Annotation panel on the Home tab. Just expand the panel down and you can see the Dimension Style tool. The drop-down list next to the dimension style shows the dimension styles available in the drawing. I'm going to select the Dim Style icon. I click the New button. I'm going to name my new style Arch_96 and click Continue. I click the Symbols and Arrows tab. In the Arrowheads section, I select Architectural Tick from the first drop-down list. The second drop-down list follows suit automatically. I choose Open from the Leader drop-down list. I set the arrow size to 3/16 inches. I change the Extend Beyond Dim Lines value to 1/8 inch. This is the amount that the extension lines extend beyond the dimension lines. I change the Offset from Origin value to 1/8 inch. This is the distance from the object your dimensions are to the extension line. I click the Text tab. I set my text style to dim text _96. In the text placement section, I choose Above from the vertical drop-down list. In the text alignment section, I choose Aligned with Dimension Line. Notice how the preview changes and starts to look like an architectural dimension. I click the Fit tab. This tab specifies how lines and arrows fit, especially if there isn't enough room. You also set the scale here. In the text placement section, I select Over Dimension Line with Leader. In the fine-tuning section, I check the Draw Dim Line between extension lines so that even if the text can't fit between the extension lines, there's still a dimension line. In the Scale for Dimensions section, I change the scale to 96. Of course, this value can depend on the size of your model and the size of the paper you're using. You can use the Scale Dimension to Layout option for dimensioning in paper space on a layout, or you can use annotative dimensions to have the dimensions resized depending on your layout scale. I'm going to click the Primary Units tab. From the Unit Format drop-down list, I select Architectural. I set the precision to 1/16 inch. From the Fraction Format drop-down list, I select Diagonal. In the Zero Suppression section, I uncheck the 0 inches checkbox to show 0 inches. Next, I select the Text tab and change the fraction height value to 0.75. And you can't do this until you've specified a unit format that uses fractions. I click OK. In the Dimension Style Manager with Arc_96 selected, I click Set Current and click Close. I'm now ready to dimension. I switch to the Annotate tab. A common issue that many users have is that they switch between adding and modifying elements and adding dimensions. This means they constantly have to switch layers to ensure that the dimensions go on the correct layer. That's not really true anymore. If you go to the Dimensions panel on the Annotate tab, you can designate what layer to use for dimensions, and dimension elements will automatically land on that layer regardless of what layer is current. I select the A Anno Dims layer from the drop-down list to assign any dimensions to the A Anno Dims layer. Just to show you how it works, I'm going to switch back to the Home tab, and you can see that my current layer is 0. I select the Linear tool and place a linear dimension on the floor plan. If I hover over the dimension I just placed, you see that the dimension is on the A Anno Dims layer. I want to place more dimensions, and an easy way to do this is to use the Dim Continue tool. I select Continue from the Dimensions panel. It picks up where I left off, and I can start placing dimensions along the lower side of the building. I'm going to place an overall dimension using the Linear tool. I'll purposely place it too close to the other dimensions. When dimensions are tight like this, it makes it difficult to read the drawing. I could just use the grips to fix the spacing. If I use the Dim Space tool, it ensures that the same spacing is used between dimensions throughout the drawing. This makes the drawing look cleaner and more consistent. The Dim Space tool is located on the Dimensions panel. Just select the Dim Space tool, select the dimension that's not going to be moving, then select any dimension you want to space. Then click Enter. Autocad automatically shifts the dimension a designated value. That value is set in your dimension style. I'm going to add some more dimensions so we can explore a few more tools. One trick I like to use is a lot of users tend to select each endpoint of a wall to select their linear dimension, but you don't need to do that. If you right-click to select Enter, and then just select the line, then the entire line will be selected, and you can place the dimension. Then use the Continue tool to place the additional dimensions. That's a lot faster and fewer mouse clicks. I have a lot of overlapping dimensions at the top of my drawing. I can use the Dim Break tool to make it easier to read the dimensions. The Dim Break tool is located on the Dimensions panel of the Annotate tab. I can add breaks to more than one dimension at a time, but in this case I just have a single dimension I want to modify. I select Dim Break, select the extension line to be broken, and then click Enter to use the Dim Break value set in the dimension style. I'll zoom in a little so you can see the change. I want to adjust the dimension on the right side of my floor plan. You can associate dimensions by simply moving the extension line. Select the end grip of the extension line and then just move it to the desired location. The dimension value updates. When placing dimensions, there are a lot of tools available inside of Autocad to help you work faster and with less frustration. Assigning a default dimension layer to dimensions ensure they always land on the correct layer, regardless of what layer you're working on. Click Enter to select an object to dimension instead of selecting the endpoints to place a dimension. Create dimension styles to ensure consistency in your drawings and to use your preferred settings. Use the Dim Space tool to guarantee that your dimensions are placed at a consistent spacing. Use Dim Break to add a gap between overlapping dimensions. Don't forget, you can associate dimensions simply by moving the extension line to a new location and the dimension will update. Annotation objects and styles are used to control the size and scale at which annotation objects are displayed in model space or layout. An annotation object can be text, dimensions, multileaders, or hatches. When using annotation styles, the process of scaling annotation objects is automated for you. Annotation objects are defined by specifying a paper height or scale, and then the annotation scales at which they should be displayed for. An annotation object can have multiple scales assigned to it, and each scale representation can be moved independently. Each viewport on a layout is assigned an annotation scale. The annotation scale of a viewport controls when the annotation object is displayed and at which size. If a scale is not assigned to an annotation object but is used in a viewport, the annotation object may not be displayed. We use annotation objects to ensure that the dimension, hatch, multileader, and text objects appear the correct size regardless of the viewport scale. It is important to follow a good workflow when using annotation scales. An annotation style means that you have designated the object, whether it is a dimension, text, multileader, or hatch, to use annotation scales. We are working in a floor plan that has dimension, multileader, hatch, and text objects. If I'm going to be using annotation properties and styles, I need to verify that the annotation icons on my status bar are toggled on. So that's the first item I'm going to check. I have 3 annotation icons on my status bar. The first one controls the display of the annotative cursor badge. This means if an object has been set to be annotative, a cursor badge will be displayed. The second icon automatically adds an annotative scale to your annotation objects if they have been set to use annotative properties. The third icon allows me to set the scale of my model space. I'm working in a floor plan that has all the object types used by annotative properties and styles. I have text, dimensions, a hatch, and a multileader. I'm going to start by looking at the multiline text. I turn on Quick Properties and then select an mText object. The mText style is 2. I close the Quick Properties dialog. I go to the Text Style tool under the Annotation panel on the Home tab to locate that text style. I highlight To and enable Annotative. I set my paper text height to 3/16 inch. I click Apply and Close. Now I can add annotation scales to this text style. If I hover over the text, I should see the annotative cursor badge, but I don't. When I modify a style and make it annotative, it does not update the existing annotation objects in the drawing that are using that style. I need to set the existing text to be annotative. I select the text, right-click, and choose Select Similar to select all the text objects in the drawing. On the Quick Properties dialog, I change Annotative to Yes. Note that the annotative scale is displayed as 1/4 inch equals 1 foot, and you may recall that my model space is set to use 1/4 inch equals 1 foot. I close the Quick Properties dialog. I click Escape to release my selection. Now when I mouse over some text, I see an annotative cursor badge. You can apply more than one annotative scale to an object. If you see more than one cursor badge when you hover over an object, that means that it has more than one scale available to it. Right now, the text has only one annotative scale, 1/4 inch equals 1 foot. I hover over one of the dimensions. No annotative cursor badge, so that means the dimension is not annotative. I select the dimension, right-click, and choose Select Similar to select all the dimension objects in the drawing. The Quick Properties dialog shows that the dimensions are not set to be annotative. I change that value to Yes. I close the Quick Properties dialog. I click Escape to release my selection. Now when I hover over dimension, I see the annotative cursor badge. Just because I changed the dimensions to annotative does not mean I changed the dimension style. I select the Dimension Style tool from the Annotation panel on the Home tab. I highlight Arch_96 and select Modify. I select the Fit tab. I enable Scale Dimensions to Layout. I enable Annotative and click OK. An annotative cursor badge is displayed next to the Dimension Style name. I close the Dimension Style Manager. I turn off Quick Properties on the status bar. I hover over the multileader. It does not display the annotative cursor badge, so it is not annotative. I select the multileader. I right-click and choose Select Similar. I right-click and select Properties. I set Annotative to Yes. The annotative scale is set to 1/4 inch equals 1 foot. I press Escape to release the selection. I hover over the hatch. The hatch displays the annotative cursor badge. Annotative objects really come into play when using layouts. I'll start with the floor plan layout. I switch to the viewport layout using the drop-down list on the Home tab on the ribbon. I select the Layout tab. I select the Rectangular Viewport tool and place a viewport on the layout. I select the viewport. I right-click and select Properties. I set the view scale to 1/4 inch equals 1 foot and the annotation scale to 1/4 inch equals 1 foot. I click Escape to release my selection. I switch to the kitchen layout. I select the Layout tab. I select the Rectangular Viewport tool and place a viewport on the layout. I activate Model Space and use Zoom Window to position the kitchen area in the viewport. I click outside of the viewport to return to paper space. I select the viewport. I right-click and select Properties. I set the annotation scale to 1 inch equals 1 foot. I set the view scale to 1 inch equals 1 foot. Notice that the annotation objects adjust their size. I click Escape to release my selection. I return to my Model tab. I'm going to use my Linear Dimension tool to add 2 dimensions to the kitchen area. I place a horizontal dimension and a vertical dimension. I switch back to the kitchen layout. I don't see the dimensions. I return to the Model tab. If I hover over one of the dimensions, I only see one annotative cursor badge. I select the 2 new dimensions, right-click, and select Properties. I see the annotative scale for the dimension is set to 1/4 inch equals 1 foot. I click in the annotative scale field. I select the Add button. I scroll down and I select the 1 inch equals 1 foot scale. I click OK. I click OK to close the object scale list. I switch back to the kitchen layout. Now those 2 dimensions are visible because the correct annotative scale was added.